Hello folks, so today I'm going to try to talk about how we connect real life to probability models. And this is definitely a work in progress as far as explaining things, so if it doesn't make sense, that's really on me. I'm going to try to explain it. We're more kind of like revisiting from another angle than introducing something totally new, so we'll see what happens. So here's a picture of Plato's cave, because models are these idealized representations of what's going on in the real world. So basically what we're saying is in our data, we have some observations of what we expect to see. Let's see. We have observations of some variables, the independent variables that we think are influencing what's going on, and then we have a response variable that we are using to measure the thing that we're most interested in. And so based on the input variables, we have an expected output. And the model is what lets us compare the expected output to what we're actually observing. And the model usually has parameters that connect that collection of inputs to the output. So that's that machine picture that I did before. And so we have the real world, which inspires questions and things that we can measure, and then we do computations to try to understand what's going on. So the point of the model is to get us from a real world question to an actionable insight. And there's this most general approach that we're not going to actually take in this class, where you say, all right, how is the thing that we're going to observe distributed? And then we come up with a likelihood equation. So you say, okay, what's the exact probability of each individual item? And then we look at every possible combination of parameters, and you compute all those, and you find the combination of parameters and model representation as the best likelihood, and that's your explanation of what you think is going on. Fortunately, in stats, better minds than ours have come before us and figured out recipes so that you can quickly do something. So like when you are using baking powder in cooking, you don't need to know what the chemistry of how baking powder works. You just throw that into your recipe and heat it up, and then you get bubbles, and you don't need to know why that works. So that's basically what these tests that we're going to learn about next week are. You look at how the variable is distributed, and you figure out what format your data should be in, and then that gives you a test that you can run and a single number that you can use to try and evaluate whether what you think is going on really is. So that's sort of the overview of models. And that was pretty vague, and that's okay. It's a framework that I hope will start to make sense as we fill in some of the details. So I'm going to stop